Hi everyone, welcome back to our channel. So today we are back with our new video in the system design playlist. So in this video we're gonna be discussing about one of the use case for system design for a mobile application. So in this video we're gonna design different components of this mobile application from very high level to a bit of low level also. So in this video, we're gonna discuss about different architecture components that are required to be used while you are building a mobile application, for which the architecture has to be scalable and resilient enough as well. So we're gonna different some aspects of those architecture in this today's video, and some of the architecture level details like performance, scalability, resilience, and all those things that we're gonna discuss maybe in the upcoming videos. So if you haven't subscribed to our channel, do subscribe to the channel please, and do like and share the videos if you like our content. So let's get started with our content for today. So let me start diagramming an use case. So for example, now the use case is we have a mobile application or we have to build a mobile application for a banking client. The banking client is into the cards application as well. So where they have a business into creating cards and publishing cards, and then uh, letting the user log in and provide different functionalities on top of that application, which can be adding different types of cards, and then having different kind of capabilities also on top of it, like they provide different services on top of it. So we're going to design all those things as we go along. So first thing is, let's look at the user. So user is nothing but the end user that we have. Now the user will come and look at the application. So I'm going to design different layers on the technical standpoint. So how it looks like. Now let's say the first layer is the mobile application. Now let's say I put a mobile application mobile here. So user comes here and opens the mobile application. Now in this mobile application there can be different modules when it downloads the application. So it's a, let's say an application which is built in any framework, like any of the hybrid frameworks or any of the native frameworks. So I'm not going into details of the languages here. So let's say it is built in any of those, and then user downloads that application from the Play Store. Now after user downloads, so there are different functionalities involved in that application. Since user downloads the application, there can be different modules also. So let's first talk about what kind of modules we can have in this kind of application. Now let me break down to back, and then I'll pull this down. So let's say this is the mobile UI, and then we have different small components here. So I'll just try and write those. Let's say the login is one of them. Login, and you call that authentication or anything related to that. Then you have the profiling. So then you have the card management and something like that. Now these all are UI level features that I'm talking about. So similar to that, there will be backend modules also, so that we're going to talk about in some of the in next few minutes. So then in the card management, you can add and remove the cards and manage their transactions and all that. So then you have the transactions, so where you get to see the transactions of the cards and how how you how you manage the cards and the transactions. So those are all things are present in the transactions module. Then you have different features on top of the cards that you're adding. For example, you add the uh, you add any feature. Let's say you add an insurance feature on top of it. So you are providing different level of insurances to your customers also. So that can be added here as well. Then you have different payment options, like you have different features like you can recharge, you can pay for something online, and you can do the payment transfers also. So what other things are there? So you can do those online as well in that application. Sorry, it's going out. Let me just make this box a bit bigger. So this is about the those are the features. Let's say these are some set of features which I've just identified. There can be some other features also, but let's go one by one and see what all things are required at the UI. Let's just put those for now. So this is our front end application, or how the user will actually download the application and see different modules. Now after that, when the user downloads the application, user has to log in. Now after login, it has to view all different modules that we just talked about. So which means there can be different set of there will be a login module in the backend services. Now before going to the backend, let's create a middleware, or I would say a layer which will actually detect the user and provide you authentication, which is I have categorized that layer into DMZ layer. Now DMZ layer will have multiple components on the architecture level. It can have firewall, it can have your gateway, so which will actually detect all these things like authentication and all those things whenever the request comes to the backend services. So this is your DMZ layer. Now in the DMZ layer, you will have different things as I mentioned. So you will have your API gateway, your firewall, all those things will come here so that it will provide security to your backend services also. Now then you will have your backend infrastructure, so which will have different backend modules with respect to your front end modules. So let's say you will have a authentication service. Now you will have card service, card management service. So I'm just quickly putting those placeholders here. Card service, and then you will have your transaction service here, and then you will have your recharge service. So I'm just putting those on very high level with respect to what we have already put into the front end layer. So then we have recharge service. Okay, so now first thing which we're talking about is the authentication. So how the authentication will happen. Now, as we know, in today's time, we see different applications that we use. So there are different set of login mechanisms also in the banking applications, for example. So you can log in with your username, password also. You can log in with your PIN as well. You can have biometric also. So you have different set of login mechanisms also itself available right now. So some of the login mechanisms would be handled on the phone. Some of the login mechanism has to be handled on the backend stuff. For example, your user login and your MPIN login. So all those things have to be managed at the backend. So you will have to create different, I would say nano kind of services for managing all these things like MPIN and user login and email login or any other login kind of mechanism. So for now, I have just put these services on very high level, but we'll have to put the PIN management services also here. PIN services. Now, most of these services which we have coined here, those will have their own databases, those will have their own structure and the model as well, based on how they exchange the data from different interfaces as well. So let's say once you log in, so you log in, you talk to authentication service might talk to PIN service for authenticating yourself, and then will issue you a token or something, and then it will let you log in. So that kind of process it will follow. But if there is a biometric login where you can log in with your finger, with your face detection, so those kind of login mechanism will have a different flow, and it will have an involvement of your mobile phone native features also, where you will store some set of features or some set of data at the mobile phone also. So there we will have to think about what kind of things we can add into the mobile layer as a module, or how we can store those biometric details also at the front end. So that we're going to talk about in length maybe in the upcoming videos of this series. So for now, let's come back to this backend stuff for now. So we talked about all these services which we have put together on the high level. Now all these services will talk to the banking system also. So it's not like the this application which we are building, it's a scratch, we are building it from the scratch, but the data which it needs, it has to have data from the backend system of the banking as well. So there has to be a banking system which is somewhat here. So for which we don't know. So where all the records are being saved, cards are saved, transactions are saved, everything is saved there. So let's say this is a legacy system to which our APIs are interacting and they are getting the required data also. So when we have this kind of use case, so where you have the entire data set into your banking system. So if you talk about those kind of enterprise applications, so there you will have to rethink, when do you need a database for your middleware services also. When I talk about middleware services, so these services which we talked about, transaction, recharge, card, PIN, authentication. So all these, most of these are middleware services, because for them the data or the entire data for these services would be stored into the banking system only. So if I talk about card service, you add a card, you save a card and then configure it and use it in your application. Now the card details which you are entering to log in or whatever, those will be stored in the banking system only. So you can store that in a separate schema or a database for the card service also in your infrastructure, but it's like duplicating the data which is already stored in the banking system. So that way, in such kind of use cases, we need to think whether we need a separate database for our set of services or not. Which are these? So if we need those services, and do we need the database also for those services? So that comes another question here. So that's where we need to think as an architect. Whenever we are designing such applications where the legacy systems are involved and we are building, or let's say modernizing an existing application or building a new application on top of the existing legacy system to where the data is also stored and all those things. So we need to think whether we need database for our services or not. So this is very important question. As an architect, you might have seen that if you have worked in such applications earlier. So here can be different mechanisms also for communication. So from this service or from this infrastructure, we are communicating to banking system. So we can communicate via HTTP also if they have REST APIs exposed. We can communicate via queues also if they want to be queue driven services. If they like, there can be different mechanism of communication like GraphQL also. The GraphQL is not necessary. I'm just putting it for highlighting here. So not necessary. So, but it depends on different parameters, what kind of communication mechanism we want to use. Because if we, let's say, the customer says that I want this kind of performance, I want the scalability. So we need to think what kind of communication mechanism we should use. So if we talk of this system here, if the customer says, I want now most of the mobile applications or most of the banking applications rather would love to have zero downtime. So in that case, we need to design our core infra, which is this one for us, in such a way that it is scalable as well, and at the same time, it is resilient enough as well to interact with the backend system of banking system to get the data as well. So when we have to provide such information, or when we have to provide such kind of architecture capability, we need to think of different architecture infra components also. Now, when I talk about this specific block where our services are deployed, if we want our services to be highly scalable, and at the same time it should be deployable anywhere, including on premises also and in cloud also. Let's say this is the first use case. So you want to deploy it anywhere. Then you want scalability also, you want performance as well. Let's talk about scalability as well first. Or not scalability, let's say high availability and all those things. So which means whenever the request comes to any of your services, so there should be an instance available to answer those requests, even if it is a highly scaled application. So it should not happen that your application is giving good performance when there are 10 users, but the moment the user crosses around 1000, your application, let's say card service, is going down and it is not able to serve those extra users. So that should not happen, which means your scalability factor, and you should be highly available also. So first let's talk about scalability, then we'll go to highly available. So in order to make these services deployable on any of the infra, let's say on premises and on cloud also, so then in that case we need to think about Kubernetes cluster. Kubernetes cluster is the first choice which comes to anybody's mind in such use cases, which means you can deploy your application anywhere, and at the same time it will be supporting your scalability factors of the services also. So as you know, Kubernetes has different configurations in itself, with which it can uh, add more and more containers of your uh, relevant services. Of course, there would be a limit, but it can add on to certain limit of the uh, scalability aspects also. It is only nothing, not that only, but we'll have to think that whenever we are scaling a service or adding a container at runtime, it should be ready also very soon. So we'll have to focus on our infra, and at the same time framework level and what all features we are using in the low level design also very carefully to support this scalability inside Kubernetes. So it's not like we'll add a Kubernetes cluster and we will add the scaling configuration and it will scale, and no matter how much load it comes, it will automatically scale and handle those requests. No, it will not happen that way. Of course, the scaling will happen, but how soon your application is ready to serve the new requests, that depend how you configure the containers to load and how quickly your application can get bootstrapped. So those are the aspects that also we need to think as well. Now, this is one of the aspect for scalability. Now, the other aspect which comes is highly available, which means um, it's not like you have a Kubernetes cluster where you have some of the availability zones, or let's say you have some cluster of, you have chosen, let's say, Bombay zone where you are deploying your services, and then uh, you don't have any other zones where you are deploying your services. So in Bombay zone you are deploying your services and you are scaling also in the same zone. Okay, that is the use case. In worst case, if Bombay zone data center goes down or the Kubernetes cluster is not working well over there, there is a networking issue or whatever, so then you will have to switch to a backup zone. But if you don't have a backup zone ready with you to handle those requests, then your application will go down if the Bombay zone is not working. So when we say highly available, which means you should have a backup zone also which should work in parallel to your Bombay zone. For example, let's say one of the zone I chose as Bombay, and one of the zone I choose as, let's say, in somewhere in Australia. Now, based on, I would have a DNS routing which will depend on that, um, um, like which is the closest data center you have. So based on that, the request will go to that kind of cluster or zone. So let's say if you are in India, your request will go to Bombay, and if you are near to Australia, your request will go to Australia. But if Australia data center goes down, so it's not like your request will stay on to Australia only, but it will come to Bombay data center. So that's where the highly availability also comes into play. So as an architect or as a developers, you might be aware that scalability and highly availability has a number involved, like triple nines, four nines, five nines, and each of them comes with a definite infra cost as well, which you have to put across in your cluster. So these are some of the careful things that we have to think whenever we are designing these services at the backend in terms of scaling and making them highly available as well. Now there is one more aspect, not onto infra, but rather onto the domain layer. So we will come to the other parts of the infra or the NFRs, like security, usability, and performance and all that in the next video. But let's discuss about one more topic, which is around domain. Now in this cluster that we are talking about, this cluster has different services, and as we earlier talked about, they may not have their own databases and they may act only as a middleware service which is talking to banking system. Okay, some of the services may have their own data because some of the services customer may have asked us to build new, which for which they don't have the feature in their banking system. So that's where some of the services may have the database, but other services maybe just acting as a middleware services or just a orchestration services. So in that case, we have talked about kind of microservices architecture here. But then if that is the case, that we have to just orchestrate most of the services, then we can think of uh, maybe hybrid architecture that will involve some of those as microservices and some of those will act as a modular monolith REST services. So which means you will have all those orchestration services in one of the I would say container as a module, and you will have to scale those that container also if each of those or any one of those modules needs scalability effort. For example, if we merge card and transaction here in one monolith rather than making separate services for them, so if card service is getting more traffic, then we'll have to scale that modular monolith along with the transaction, which is not getting that many of requests, it will also get scaled. But with this kind of orchestration that we decided, if card service is only getting the extra traffic, which needs a scalability containers, so then this service will only have the more containers added to it. It's a debatable topic. We can discuss about this more if you want to understand about this more in the please drop me in the comments. But this is one of the major architecture decisions that we have to make sometimes, considering different requirements that customer has. So we'll have to drill down through the customer requirements and see what is actually their core requirement to decide whether we should go for separate services or whether we should go for modular services as well. So this is about the today's content. I hope you like the video. If you do like the video, do share and like the video and subscribe to the channel. We'll come back again in this series with new set of content and we'll extend this content as well. Thank you. Have a nice day.